So the first step of these problems is to state the possible rational zeros for each function. What are the possible rational zeros for this one? It's not a very long list, is it? Plus or minus 1 or plus or minus 11. And again, we don't have a coefficient here to deal with other than 1, so there's no fractions that are going to come into play. All right, so we're going to start out testing to see 1x cubed, negative 11x squared, negative 1x plus 11. What do you want to try first, Zach?
1.
Try 1. Bring down the 1. Multiply times 1. That gives us 1. That's negative 10. That's negative 10. Zach has picked a winner. This is going to be negative 11. That's negative 11, which means 1 is a 0. All right, so one of our solutions, one of our zeros, roots, we called them yesterday, is 1. All right, now the resulting quadratic quotient here, x squared minus 10x minus 11, is going to have the rest of our zeros. Can that factor?
Yes.
It can, right? X minus 11 times x plus 1 equals 0. So the other two solutions would be 11 and negative 1. Okay. All right, so this is really similar to the problems that we did in class yesterday, really similar to the one that you guys were to do for homework last night. But I want to kind of point out something to you here, all right? How many terms are here? How many terms? 4 terms. How are you taught to factor 4-term polynomials? Because I want you to think about factoring as a possibility for solving these equations, okay? How would you factor this 4-term polynomial? By doing what? This is coming up on the exam again, right? So we've got to remember all of our factoring skills. The first 2 terms there have a common factor, x squared, right? And that'll leave me with x minus 11. This term is negative. We're going to take out a negative.
Is that supposed to be 11?
Yes. Thank you. We're going to take out a negative 1, and what will that leave us with? X minus 11, right? So we can factor out x minus 11, and we're left with x squared minus 1, which will factor as the difference of 2 squares. So we can see the 3 roots from those 3 factors. All right, so don't rule out factoring as a possibility for solving these equations. Okay, factoring can be a possibility right from the outset. And sometimes we're forced to factor. Okay, let's look at number 6 on your sheet there. 6, I think it's the next one I want to work. 6, not 5, but 6. Okay, x to the 4th plus 16x squared plus 63. It says, state the possible rational zeros for each function, then find all the zeros. How many zeros does this one have?
5.
It's going to have 4, right? Because it's a 4th degree polynomial. Now, there could be repetition. In other words, we could have one of our factors twice. I don't know if that's the case with this problem. But what are the rational zeros here? A lot of them, right? All the factors of 63. Plus or minus 1, plus or minus 3, plus or minus 7, right? Plus or minus 9, 21, And 63, I think that's about the only combination that's left that'll go into this. Okay? Y'all ready to start trying some things? I tell you what, y'all put your pencil down because I can erase and do this really easily here. Just throw out what you want to try first. 7. Okay? I got a 1x to the 4th, 0x cubed. Well done. 16x squared, 0x, and 63. Okay? Bring down the 1. 7 times 1 is 7. It's 7. 7 times 7 is 49. That's 65. And we could stop there, right? How do we know we could stop there? Yeah, I mean, everything's positive, and these numbers are just going to keep getting bigger. Right? Isn't that true for every positive number that I put out there? Am I going to be able to get a negative at the end if I have a positive on the outside? All right, so, I mean, maybe there's a shot if we did this. That would give us, what's that going to give us? Negative 33. That's not going to work either, right? Okay, so let's try a different number. Let's try something smaller. But we know it has to be what kind of number? Negative, right? Negative 3. We'll try negative 3. Let's see, this 1, that's negative 3, that's negative 3, that's negative 9. 7, negative 21, negative 21. It would be positive 9, which makes that 25, which makes this negative 75, and my hopes have been dashed. Yeah, I made a mistake, and you're correct. Good catch. 10 peso points for you. All right. So negative 3 doesn't work. What if I told you none of these numbers work? It's just not looking hopeful, is it? So we're going to have to resort to some other technique for solving this. So get creative. Think about how we might solve this problem. It's solvable. You have the skills to solve it. You can probably factor it, right? It's not a quadratic, but it is quadratic-like, isn't it? It's a trinomial. The middle term is half the degree of the leading term. How would we factor this? We need an x squared times an x squared, wouldn't we? Are there any factors of 63 that add up to 16? 7 and 9. Both positive, right? Now we're on to something. X squared plus 7 equals 0, or x squared plus 9 equals 0. Now neither of those are factorable, right? Because sum of squares, you could factor it over the imaginary numbers, and some of you know how to do that. That's great. But we could solve by taking square roots. So here x squared equals negative 7. Here x squared will equal negative 9. X equals plus or minus the square root of negative 7, which is I times the square root of 7. And here x equals plus or minus the square root of negative 9, plus or minus 3i. So all 4 of my solutions are imaginary. It's kind of like gloating, you know, bringing that big Starbucks drink in here and just relishing it in front of everyone. All right. Let me tell y'all something. Beware if you have all positives. Beware. This is going to happen a lot. If you have all positive terms, it's just the the function is not being pulled up and down much. Everything's increasing. Everything's positive, right? So this thing just opens up and has only imaginary solutions, okay? And that's not always going to be the case, but just beware. Beware of that as a possibility. All right, let's look at one more, and then I'm going to turn y'all loose. Number 8. All right, so again, let's don't ignore the instructions. State the possible rational zeros for each function. Now this one is one of the first ones that we've encountered that has a coefficient up front that is not 1. So these factors are going to be the denominator of my rational roots, if we have any rational roots. Okay. What are the possibilities here? Possible rational roots. Plus or minus 1, plus or minus 2. Then these two factors over the factors of 25. All right, so what are the factors of 25? Plus or minus 5 and plus or minus 25, right? So I got plus or minus 1/5, plus or minus 2/5, plus or minus 1 over 25, and last one, plus or minus 2 over 25. So the way we wrote this yesterday in class was the factors of this number, which were plus or minus 1, plus or minus 2, all over the factors of this number, which are plus or minus 5, plus or minus 25. Of course, 1 divides that number. That's boring. Okay, so we got plus or minus 1 over 1, plus or minus 2 over 1. That's where we got those from. Then you got 1/5, 2/5, 1/25, 2/25. You see where all the factors came from. All right, so where do you want to start? Y'all working? Where do we want to start? 1/5. That's where you want to start? I'm all for starting with 1/5. Zach said start 1/5. 25x to the 5th, 5x to the 4th, 35x cubed, 7x squared, 10x, and 2. Bring down to 25. 1/5 of 25 is 5. That's 10, right? 1/5 of 10 is 2. That's 37. 1/5 of 37 is 37/5. I think we've gone awry here. But what about negative 1/5? Again, look, all of your terms are positive, right? So if you put a positive number on the outside, what's going to happen? It's going to get bigger and bigger and bigger. Is there any possible way we could have a positive number out here, and end up getting -2 right there? It's not possible, right? So it makes sense to try negative values. And Zach said 1/5, so while we're at 1/5, let's try negative 1/5, Zach. Because I like the 5th idea. I really do. Because my first few numbers are divisible by 5, so why not? It's got potential. Let's try negative 1/5. Let's bring down to 25. What's negative 1/5 of 25? -5. That's a 0. I love zeros. Negative 1/5 times 0 is 0. 35 comes down. 1/5 of negative 1/5 times 35 is -7. I'm liking this. It's got potential. 1/5 times 0 is 0. 10 and 0 is 10. And negative 1/5 times 10 is negative 2. There we go. Zach 1, everybody else 0.
10 peso points.
10 peso points. 10 peso pointos. All right. So what is left over here?
25x to the fourth plus 35x squared plus 10.
All right, so 25x to the fourth. I'm going to write it right here. 25x to the fourth. 0x cubed, 35x squared. 0x plus 10 is what we're left with. I'm going to erase all this out of our way here. Ooh. Okay, so we have one of our zeros. We found one. It's negative 1/5. And then we're left with this. Yeah, if we set this equal to 0, we can indeed make this 5x to the fourth plus 7x squared plus 2 equals 0. Good instinct, Kirsten. All right. And then that looks like something we could at least try to factor, doesn't it? Will it factor? What's 5 times 2? 10. Are there any factors of 10 that add up to be 7? 5 and 2, right? So this will factor as 5x squared times x squared. I need 5x squared and 2x squared to get the other zeros. All right. And then we can solve each of those by taking square roots, right? Five x squared equals negative 2. Divide by 5 and take the square root. What are we going to get? Plus or minus I times the square root of 2/5. Now that's not a rationalized expression, but I'm going to let you leave it that way. Okay. To rationalize that, you'd have to multiply by 5 over 5. You get square root of 10 over 5. I times the square root of 10 over 5. And this other one, you get x squared plus 1 equals 0, which means x squared equals negative 1. Take the square root of both sides there, the square root property, plus or minus the square root of negative 1, plus or minus I. Yes?
Can you do it without taking the 5 out?
Yeah.
Can you do that?
Yes, I can. All right, if we do this without taking the 5 out, we still are going to have to factor it. We know that now after the fact because most of these, all 4 of these remaining answers are imaginary. We can't find imaginary solutions using the rational root theorem because they're not rational. So we got to use one of our other techniques. So the factors of 25 times 10 that add up to be 35 are 25 and 10. Okay, so I think this would factor like this: 5x squared times 5x squared, and I need to get a 25 and a 10. So I need a. Let's make this the 25. 5 times 5 is 25. 5 times 2 would give us 10. And 5 times 2 is 10, so that factors that way. And then it's the same game, right? You subtract 5 and divide by 5, you get negative 1. If you subtract 2 and divide by 5, you get negative 2/5, and it's the same 4 solutions that we got the other way. So if you don't recognize that you can take out a GCF, you can still solve by factoring. But factoring is required either way you go on that problem. Y'all want to do one more, or you feel okay with these? One more? Let's see which one we want to do. Can I see your sheet?